So chapter 1, database system. On this chapter or topic, uh, we will uh, we will learn about the difference between data and information. So what is the database, and about the different types of database and why they are a valuable asset for decision making, and also why database design is important, and how modern database evolved from files and file system. So another, we will discuss also about the flaws and file system and data management, and how a database system differs from the file system, and how a DBMS or database management system function within the database. So data versus information. So what is the difference between the two? So the data, they are the raw facts, building blocks of information. So another, unprocessed information. And for information, data is being processed to reveal meaning. So it means, for example, data is your name. So for example, the name is Juan de la Cruz. So that is data. And how about the information? So information means the detail, or the detail of Juan de la Cruz. For example, where Juan de la Cruz resided, what is his birthday, and etc. So that is information. So accurate, relevant, and timely information is key to good decision making. So a good decision making is the key to survival in global environment. Um, so let us introduce the database and DBMS, or the database management system. So database is a shared integrated computer structure that houses. So we have the end user, or the raw data facts, and metadata, the data about the data. So DBMS, database management system, is a collection of programs that manage database structure and controls access to data. And we have the possible to share data among multiple application or users. So makes data management more efficient and effective. And for the DBMS makes data management more efficient and effective, we have the end user have better access to more and better management data. So to promote integrated view of organization of operations, probability of data inconsistency is greatly reduced, and we have also the possible to reduce quick answers to ad hoc queries. So we have here example in the figure 1, which shows the data DBMS manage the interaction between the end user and the database. And as you can see in the illustration, we have shown in the we have the end user. So this is the application request, and then it goes to DBMS, or database management system, and then after this it will go to our main database server, which is the data structure, as shows as metadata, customer invoices, and product. Next, we have the types of database. So we have the single user, desktop, and multi-user. Single user support only one user at a time. And for the desktop, single user database running on a personal computer. And for the multi-user, we have the supports multiple users at the same time. So another, we have the workgroup and enterprise. So workgroup, multi-user database that supports a small group of user or a single department. And then for the enterprise, we have the multi-user database that supports a large group of users or entire organization. So meaning, for example, a big structure like a big company, not only in a company dealing with the server and client, but also what if our that big multi-company has different branches, not only domestically but internationally. So, like for example, what we're using right now is the web. For example, the social media, the Facebook. So, of course, social media is using database. Of course, imagine how many or billion of people subscribe to Facebook. So, imagine how hard the database server manage the the users connecting to a one server. So that is for example an enterprise enterprise database. So next we have another example here. We have the location of databases. So which means we have two kinds, no? Centralized and distributed. Centralized is to support data located on a single site, meaning if you have small office with you and a small company which has a small office and with no branches, so that means the centralized. And how about distributed? So support a data distributed across several sites, meaning if you have for example of this distributed is the bank. The bank has multiple branches all over all over the country. For example, domestic, or not only in domestic, but of course they can connect also internationally. So that is an example of a centralized and distributed database. Transactional or production, so supports a company's day-to-day operation. And then another is data warehouse, so store data used to generate information required to make tactical or strategic decisions, and such decisions typically require data messaging, so often used to store historical data structure is quite different. So example ng transactional is like bank. You have open a bank account in Manila branch, and then what transactional means is real time. So you wanted to withdraw in Cavite branch. So since that is online, so automatically it updates the database of its branches. So how about data warehouse? So data warehouse is like a central repository of information that can be analyzed to make more information decision. So example of this is we have the business analyst, data engineer, data scientist, and decision makers access. Like for example, we have the business intelligence or the BI, and we have the SQL clients and analytics applications, and if you are already familiar with the data mining, so that is like similar to business intelligence. So why database design is important? So of course it defines the database expected use, different approach needed for different types of database, and avoid redundant or unnecessarily duplicated. And also poorly designed database generates error, so lead to bad decisions, can lead to failure of organization. So let's go on to historical roots of database, files, and file system. Although managing data through the system is largely obsolete, and understanding relatively simple characteristics of file system makes complexity of database design easier to understand. So awareness of problems that plague file system can help prevent similar problems in DBMS. And then knowledge of file system is helpful if you plan to convert an obsolete file system to a database. So imagine if you convert your file to database. Well, as part of DBMS, they have the so-called the recovery or business continuity. Unlike, for example, you have your file with you, and then anything goes wrong, like for example disaster happens or accidentally you cannot retrieve your file. Unlike database, we have the so-called management policy. So as part of the policy, we have the so-called auto recovery. Next, let's go on to manual file system. So traditionally composed of collection of file folders kept in file cabinet. So organization within folders was based on data expected use, ideally logically related. And then system was adequate for small amounts of data with few reporting requirements. So finding and using data in growing collection of file folders became time-consuming and cumbersome. So let's go on to conversion of manual file system to computer file system. So could be technically complex or requiring hiring of data processing or DP specialist. And then the DP specialist created file structure, wrote software, and designed application program. It's like a programmer. And then resulted in numerous homegrown system being created. And then initially computer files were similar in design to manual files. So as shown in figure 1.3. So this is an example. Uh, as you can see in the illustration, contents of the customer file, they already consolidated or planned the file. So as you can see also in this is different from Microsoft Excel or Word, Office Excel, or different versions of Excel. So as you can see in the header or field, we have a different field identity. So as you can see in the name, or they place C underscore name, like that is a it's a mark, or for us to remember that is a character. And then they also put an A, like a name. Or okay, so let's go on to basic file terminology. We have as shown in table 1.1, we have the term data, field, record, file. So for the data, definition of data is raw facts such as telephone number, birth date, customer name, and a year to date or YTD, sales value. So the data have the little meaning unless they have been organized in some logical manner. So the smallest piece of data that can be recognized by the computer is a single character, such as the letter A, the number 5, or a symbol such as backslash. A single character requires 1 byte of computer storage. And how about for the field? So a character or group of characters, or alphabetic or numeric, that has a specific meaning. So field is used to define and store data. And for the record, so a logically connected set of one or more fields that describe person, place, or thing. For example, the fields that constitute a record for a customer name JD, root might consist of JD or Ruth's name, address, phone number, date of birth, credit limit, and unpaid balance. So how about for the file? A collection of related records. For example, a file might contain data about vendors of RobCorp, example, RobCorp company. So, or a file might contain the records for the students currently enrolled in the gigantic university. So, example of early database design, we have the DP specialist wrote programs for reports, so monthly summaries of types and amounts of insurance sold by agents, monthly reports about which customer should be contacted for renewal, and reports that analyze ratios of insurance types sold by agent, and then customer contact letter summarizing coverage. And another additional reports were written as required. So, example nito class is, for example, is if we will be comparing database to Microsoft Excel, what if you have multiple files in Excel and then you misplace, or you can't remember where you save your file? So that is very difficult to find. Unlike designing or implementing database, we have this that the programmer already organized and customized based on the requirements of the company. So it is already your file is already consolidated in one system. So you you wanted to search or locate a file, and then you can locate your file um, easily compare to a traditional file. And then, for example, accidentally you misplaced the file, and then another thing happened. There was your computer was experiencing bad happened to, for example, to your computer. So well, you cannot retrieve your file, unlike organizing the whole file or the company's file. So it will also the company will also benefit for this, like it will avoid time consuming. So next, other departments request the database be written for them. So example of this, like sales and agent. So sales database created for sales department, and then agent database is created for personnel department or the human resource department. So another example here, the contents of the agent file. Don't worry, class. I will demonstrate also in our next chapter the creating a basic database using Microsoft Access. Then after using Microsoft Access, we will go on to Microsoft SQL Server and MySQL. Okay, so another example here. This is the example of agent file using Microsoft Access. Sorry. So we have the name, phone, address, zip, hired, year to date, fit, and so on. Next, evolution of simple file system. As number of database increase, small file system evolved. So each file uses its own application programs, and then each file has owned by individual or department who commission its creation. So another illustration here, figure 1.5, simple file system. So we have the personnel department and then the sales department. So as you can see, we have two database in sales department, the database customer file and then the sales file. And then for the personnel department, we have database for the agent file. So another, as system grow, demands for DPs or programmers skills grow. So until now naman mataas ang demand sa mga IT. So additional programmers are hired. DP specialists evolve into DP manager, supervising a DP department. And then also we have the primary activity of department, and the DP manager remain programming. So problems with file system data management. So every task requires extensive programming in the third generation language, or the 3GL. And then also, programmer must specify task and how it must be done. So how about the 4GL or fourth generation language? Modern database use fourth generation language, which is the Microsoft. So allows user to specify what must be done without specifying how it is to be done. In programming in 3GL, time-consuming, high-level activity, which is as far as I remember, the 3GL database is like a DAT file, and then the programmer must be familiar with physical file structure, and a system becomes complex access paths because difficult to manage and tend to produce malfunction. And then complex coding establishes precise location of file and system components and data characteristics. And another, we have the ad hoc queries are impossible. So writing programs to design new reports is time consuming. As number of files increases, system administration becomes difficult, and then making changes in existing file structure is difficult, and then file structure changes require modification in all programs that use data in that file. So when I was working on that DAT file, so it's very difficult, especially handling large data. So every time I search or I locate a file, it is a time consuming. It will take an hour before I search that file. So next, modification are likely to produce errors requiring additional time to debug the program. And then we have the security features hard to program and therefore often omitted. So how about structural and data dependence? So structural dependence, access to file dependence on its structure. So we have the data dependence. Changes in database structure affects programs' ability to access data. And then logical data format, how a human being views the data. And then physical data format, how the computer sees the data. So in field definition and naming convention, flexible record definition anticipates reporting requirements by breaking up fields into their component parts. So example of naming convention is as earlier in our example in agents file, and the other one is the sales table. So remember the heading of the field. That is what we call the naming convention, the C underscore name, and then the other one is the A underscore name that stands for the agent. So here, this is the customer file fields or example of naming conventions. So the naming conventions here, we have format. We follow format based on the but that is in the field side. Then the contents, like for example, the customer last name, and then the sample entry. Here is the sample customer. Next, how about data redundancy? So data redundancy results in data inconsistency. So different and conflicting versions of the same data appear in different places. So errors more likely to occur when complex entries are made in several different files and recur frequently in one or more files. So data anomalies develop when required changes in redundant data are not made successfully. And then for the data anomalies, modification anomalies occur when changes must be made to existing records, and insertion anomalies occurs when entering new records. And then deletion anomalies occur when deleting records. So database versus file system. So problems inherent in file system makes using a database system desirable. So file system, many separate and unrelated files. And then for database, logically related data stored in a single logical data repository. So another example here as shown in figure 1.6, contrasting database and file system. So as you can see here, that we have the personnel department, sales department, and the accounting department. It goes through DBMS, and then the DBMS, we have the central database. And then another example here is an ordinary file system, which is different file, like different computers. So it's very difficult to locate a file, or for example, for a manager, I wanted to have the report of the personnel department. So I will get the attention of the personnel department to provide me a copy of their database. Unlike or file, no? Unlike if you have a centralized database, instead of calling the attention of the personnel department, I can call the attention of the IT department, so that the IT department, I wanted to have data, so the IT department can provide me information about that department. If I am the authorized person, such as the CEO or the chairman of the company. Next, how about the database system environment? So the database system is composed of 5 main parts. So we have the hardware. Of course, the software will not run without the hardware. So the software, As a software also, it requires a requirement. So they based on the specification of their hardware. If you're using an old version of hardware or low memory, so another thing is um, a lower version of a process. So I think that we will have an issue running the software. So for the software, we have the operating system software, the DBMS software, the application program and utility software, and then of course the people, the procedures, and the data. So that is the 5 main parts of the database. So next, another illustration example here, the database system environment. So we have here shown from system administrator supervises the database administrator, and it goes to write and enforces. So of course the end users goes to application programs, and then of course the programmer side, the programmers after getting the data, the programmers write the program for the end user, and then for the end user the data goes through the DBMS, and then after the DBMS it will go to data, and then data goes to the server or the hardware. Next, how about the DBMS function? So performs function that guarantee integrity and consistency of data. So we have the data dictionary management, defines data elements and their relationships. Data storage management, stores data and related data entry forms, reporting definition, etc. And then data information and presentation, translate logical requests into command to physically locate and retrieve the requested data. So next we have the security management, enforces users, security and data privacy within the database. So multi-user access control, it creates a structure that allow multiple users to access the data. And then as mentioned earlier, the backup and recovery management as part of the DBMS provides backup and data recovery procedures. And then the data integrity management promotes and enforces integrity rules to eliminate data integrity problems. And then the data access language and application programming interface provides data access through the query language. And then the database communication interfaces allows database to accept end user requests within the computer network environment. So another example, or the illustration shows an example of Microsoft Access. As we go to another chapter, I will demonstrate how to create a simple database using Microsoft Access. And again, Microsoft Access is different to Microsoft Excel. Okay, another example here shows the Oracle database. But as you can see here, this is a lower version of Oracle. Okay, for the summary, information is derived from data, so which is stored in database. And then to implement and manage database is use a DBMS. So database design defines its structure, and good design is important. So database were preceded by file system, and then because file system lack a database or DBMS file management becomes difficult as file system grows. And then the DBMS were developed to address a file system inherent weaknesses. So this will end my topic or presentation. I'm Dr. Errol Pantoja. Thank you for listening. So if you have question and answer, you just email me errolpantoja@gmail.com, and or you can search me through my, or send me a private message to my Facebook account. You can search Errol Pantoja. So that's all for today, and I hope to see you on my next chapter. Okay, thank you very much and goodbye.